This is the solution to problem jet lag. In this problem, you are attending the World Finals and your schedule is very busy. You can have up to 200,000 activities and you wish to attend all of them. However, you are very tired, so you will start by sleeping for some amount of time. After you have slept for X units of time, you will be awake for X units of time. During this middle X units of time, you cannot go back to sleep. Afterwards, you are off of your high of being asleep, and within the next X units of time, at some point within this interval of time, you must go back to sleep. When you go back to sleep, you can then sleep for as much time as you want. However, there is a constraint that you must attend every single activity at the World Finals. So let's first solve a simpler problem. So if we want to attend every single event, but we don't have to consider the constraint of the first X units of time after we have fallen asleep, being forced to stay awake, we can employ some sort of a greedy strategy. So what we can do is we can sleep starting from t equals 0 all the way to the very first activity. And so after we have slept for that amount of time, we can then evaluate from the interval starting 0 units ahead of time to 2x units ahead of time, when we can next fall asleep, and we can just pick the best interval that lets us go for as long as possible. So in this example, we would schedule our second sleep in this interval of time, and then we would wake up right before activity 2. We would stay awake all the way through activity 2, and then we would be done. So this works in this slightly easier problem where we don't have this constraint of needing to be awake for the first X units of time. So now let's go back and reintroduce this constraint. So this constraint actually is meaningful. So if we look in the second example here, if we were to maximally sleep all the way through, and then we would run into a situation where we are forced to be awake for the whole next interval of time, and afterwards we would continue to stay awake, but then we would fall asleep in the middle of this event, and that would be unacceptable. But note that because we could have had a sleep schedule where we didn't use this constraint, what we can actually do is we can massage a solution to the unrestricted problem and then convert it to a solution to the restricted problem. So notably, the unrestricted sleep schedule would look something like this. Our first sleep is here, and then our second sleep is here, and then we would be done. But what we can do is we can just manage the first sleep such that instead of sleeping as much as possible, we sleep for just enough time that we stay awake right until the end of the first event. So our first sleep time looks like this now, and then we have this like forced awake time, and then we would have our normal second sleep segment that is just as long as it would have been in the unrestricted version. So in this problem, we were given that there were up to 200,000 activities that we could perform, and we merely have to output some sleep schedule that has at most 10 to the 6 segments. Under this construction, we can observe that in the unrestricted problem, we would have 2 times 10 to the 5 segments at most. Some might be skipped because we can get away with staying awake for longer and then sleeping for longer. In the restricted version, any such solution to the unrestricted problem can be converted to the restricted one, where we at most double the number of segments. So this is a viable strategy.